In this video, we will discuss about Hartley oscillator. Before going to discuss about Hartley oscillator, we will discuss some questions which are generally asked in the examination. The oscillations produced by an ideal LC circuit or tank circuit. LC circuit is also called tank circuit, and they are undamped or damped. The answer will be undamped because here it is given ideal LC circuit. If the LC circuit is ideal one, then you should write the oscillation is undamped. But if the in Hartley oscillator, it is not a ideal LC circuit, so the oscillation produced by Hartley oscillator, it is damped type. In Hartley oscillator, we use a transistor. The second question, in an LC transistor oscillator, the active device is dash, that is the transistor. You should remember it. In the Hartley oscillator, you will use a transistor, and that transistor is an active device. The third question, in an LC circuit, the energy oscillates between inductor and capacitor. You should remember this question. In an LC circuit, the energy oscillates between dash, that is the inductor and capacitor. In the LC circuit or tank circuit, you have a inductor and you have a capacitor, and the energy, that is the electrical energy, is converted into magnetic energy, and the magnetic energy again converted into electrical energy. Electric energy by the capacitor and magnetic energy by the inductor. So there is conversion of electrical to magnetic and magnetic to electrical. You should remember it. The fourth question is, in Hartley oscillator, the feedback is dash, whether it is inductive or capacitive. I will discuss that how in Hartley oscillator the feedback circuit use a positive feedback circuit. What is that positive feedback circuit? Whether it is inductive or capacitive. You remember the circuit is a inductive feedback circuit. The next question, in Colpit oscillator, the feedback is inductive or capacitive. You remember in Colpit oscillator, the feedback is capacitive, it is not inductive. I will discuss it in the video Colpit oscillator. Hartley oscillator is widely used in dash. Remember, this is very useful question. Hartley oscillator is widely used in radio receivers. We will discuss it. And Colpit oscillator is widely used in dash. Colpit oscillator is used in radio transmitters. Remember, Hartley oscillator is used in radio receivers, and Colpit oscillator is widely used in radio transmitters. Now let us discuss about Hartley oscillator. In long question section, you will be asked to draw the circuit diagram of a Hartley oscillator and explain its action. Give the expression for the frequency of oscillation and discuss the merit, demerits and uses. So what is Hartley oscillator? Hartley oscillator is a sinusoidal oscillator, and it is a feedback oscillator, sinusoidal and also feedback. And what type of circuit gives you oscillation? That is the LC circuit. That is why Hartley oscillator is also called a LC oscillator, and it produces sinusoidal wave or sine wave, and it is a feedback oscillator. So you should write Hartley oscillator is a sinusoidal feedback LC oscillator. Then let us discuss about the circuit diagram. This is the simple circuit diagram of Hartley oscillator. You see, this is a PNP transistor, and you have three resistors. One is your R1, R2 and RE, and one capacitor CE. So these are the resistors, three resistors and one capacitor. They are useful for the stabilization of the circuit. That means biasing of the circuit and the stabilization of the circuit. I have discussed it in the previous video, that is the transistor biasing and transistor stabilization. Into why we basically need transistor biasing and transistor stabilization to find out the Q point or operating point. And these resistors R1, R2, Re along with the capacitor Ce, which is called your bypass capacitor. This capacitor is called your bypass capacitor. They are useful for transistor biasing, and here the biasing is called the voltage divider bias. And about voltage divider bias we have discussed in the previous video. And this voltage minus VCC, this is called the collector supply voltage. That means we give some voltage to the collector circuit, and here CB, you see you have a capacitor CB, this is called the blocking capacitor. And to the collector circuit, you see you connect a tank circuit. This is your tank circuit or a LC circuit. You have a inductor, this is one inductor and it is central tap, and one capacitor. Inductor and capacitor, this constitute a LC circuit. And I have discussed about LC circuit, how you get sustained oscillation in LC circuit in previous video. So in the circuit diagram only you write what these resistors and capacitors, what are the use of these resistors and capacitors, and how this LC circuit you are getting positive feedback from this LC circuit. I will discuss it. In the answer you should write this thing, that is what is collector supply voltage, VCC your collector supply voltage, CB your blocking capacitor, C is the bypass capacitor, R1 R2 is the base resistors, Re is the emitter resistor, and L1 L2 C they are the tank circuit, and what are the use of these components you should write. Now let us discuss the working of the Hartley oscillator. As we know, the transistor which is in common emitter configuration, that will produce a phase shift of 180 degree between input and output voltage. And here you have two voltages. You see in the circuit diagram, you have two voltages. One is your V1, another one is your V2. And the output voltage is V1 plus V2. And a fraction of the output voltage, that is V1, again it is fed to the input. When it is fed to the input, it is called positive feedback. Okay, so feedback voltage is a V1 is your feedback voltage. This V1 is your feedback voltage, and feedback voltage is a part of the output voltage V1 plus V2. So when an AC is applied or AC voltage is applied to the coil, suppose L2, the resulting magnetic flux induces a voltage in the coil L1 which is 180 degree out of phase. Okay, you see by means of this source, that is collector voltage source, you give some voltage to this inductor L2. It is one inductor, there is no partition of the inductor, it is one inductor and it is central tap. Okay, when you give some voltage to this coil L2, what will happen? That will produce a magnetic flux. Okay, and this magnetic flux will induce a voltage in this, that is L1, and this induced voltage which produces due to this induced magnetic field, that is 180 degree out of phase from this voltage, and this voltage 180 degree out of phase voltage is fed to the input, and you have 180 degree phase difference for this transistor, and here also you are introducing a 180 degree phase difference. So what will be the total phase difference? The total phase difference will be equal to 360 degree or 0 degree. That is why it is a positive feedback, and you give positive feedback to the transistor, and your circuit works as a oscillator. So you should write it, when an AC voltage is applied to the coil L2, the resulting magnetic flux induces a voltage in the coil L1 which is 180 degree out of phase. Therefore a total phase shift around the loop is 360 degree or 0 degree, and this is very important, how you produce a phase shift of 360 degree for positive feedback. Thus a positive feedback is produced for sustained oscillation. And the next thing we should know, what is the frequency of oscillation. You can find out the frequency of oscillation during the resonance of the LC circuit, and during resonance, reactance produced by the capacitor is equal to the reactance produced by the inductor. So 1 by omega c is equal to omega L, or omega square is equal to 1 by LC, or omega is equal to 1 by square root of LC, and omega is equal to twice pi f. F is the linear frequency, omega is the angular frequency. So 1 by twice pi f is equal to 1 by square root of LC. So f, the frequency of oscillation, is equal to 1 by twice pi square root of LC. So you should remember this formula. Short question will also come, what is the frequency of oscillation in Hartley oscillator. The frequency of oscillation is given by 1 by twice pi square root of LC, and problem will also come from this formula. The next thing in Hartley oscillator is the advantages. What are the advantages, disadvantages, and uses in a Hartley oscillator? What are the advantages? You see, the frequency may be adjusted using single variable capacitor or variable inductor. If you suppose you make the inductor fixed and vary the capacitor, the frequency will also adjust, can be adjusted. Or you fix the capacitor and take a variable inductor, then you can also adjust the frequency. This is the one advantage in LC circuit. The second advantage is the output amplitude is constant over a fixed frequency range. Suppose you in Hartley oscillator you take a fixed frequency range, and for that frequency range the output amplitude is constant. So you use Hartley oscillator in circuit where you need constant constant output amplitude. The third useful thing in Hartley oscillator is, instead of using a large transformer, you use a single coil. Sometimes we call this single coil as auto transformer. So auto transformer is used, or a single coil is used in case of the Hartley oscillator whose size is small in comparison to large transformer. What are the disadvantages of Hartley oscillator? The main disadvantage is, for low frequency oscillation you cannot use Hartley oscillator. As I have discussed, for low frequency oscillation you need the RC, phase shift oscillator. You cannot use Hartley oscillator for low frequency oscillator, for low frequency oscillation. This is one disadvantage in Hartley oscillator. Another disadvantage is, Hartley oscillator produces a distorted sine wave. Okay, this is also main disadvantages. You have distortion in the sine wave in the output sine wave of the Hartley oscillator. And what are the uses of Hartley oscillator? Hartley oscillator mostly used as a local oscillator in radio receiver. In radio receiver we generally use Hartley oscillator. Another use of Hartley oscillator is, it is used as radio frequency oscillator or RF oscillator. So these are the questions generally asked in the examination. In the next video we will discuss about Colpit oscillator and what are the main difference between Hartley oscillator and Colpit oscillator. Thank you.